In this video, I will show how to graph a trigonometric function using linear transformations. So first step is to write the function in a way that we can interpret all the transformations. So that means here we're going to write what's inside of the sine function in this order, and I'm going to factor -3 out. And now, since sine is an odd function, negative from the inside can be passed on the outside. So we actually have -1/2 sine of 3 times x minus pi over 3. And now we can interpret all the transformations. So negative means we're going to flip the function, flip the graph of sine upside down. 1/2 means that the amplitude of the given function is 1/2. Minus pi over 3 means we're going to shift it to the right by pi over 3 units. And this factor of 3 means the new period will be 2 pi, which is the period of the sine of x, divided by 3. So basically, when you have a stretch compression by a factor of 3, everything horizontally will be compressed by 3, including the period. Now, I would like to recall that the sine function on its 1 period interval looks like this. So that's the graph of the sine function. And when we flip it upside down, the graph therefore will look like this. On 1 period. So now we're ready to graph. Just going to fix that. So to start, we're going to first take what used to be the origin and move it according to the linear shifts. So in this case, pi over 3 to the right. To move it pi over 3 to the right, I'm going to introduce a scale. So vertically, 1 unit will be 4 squares. And horizontally, we're going to have, since we're using pi over 3, maybe I'll define 1 pi to be 6 units or 12 units. So we can do 12. So if this is pi, that means this is pi over 2. This is pi over 4. And pi over 3 will be 4 units. Like this, and 2 pi over 3 will be 8 squares, and so on. So we're going to shift the point that used to be the origin pi over 3 units to the right. So it now comes over here. Now I'm going to use the amplitude and go from this point half units up, half a unit up, and half a unit down. And actually, it wouldn't hurt to have vertically 1 unit going 8 units. So going half a unit up will extend this up to here and down there. And from here we're going to draw a box with height 1, so 1/2 in each direction from the origin, and 2 pi over 3 wide. So from this point I'm going to count 2 pi over 3. Pi over 3 plus 2 pi over 3 is pi. and I'm going to draw this box. So again, what is special about this box is that its width is exactly 2 pi over 3, which is a new period of a function, and its height is exactly 2 amplitudes. And this box I'm going to divide into segments, and in this grid I'm going to fit the shape negative sine x. So the graph will look like this. Now if I need more periods, I will just copy and paste this. It will be another 8 squares, and I'll just repeat this process again and again. So this will be here, 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 and here. And we can do that same thing going to the left. So the graph looks like this. So now, if we need to find the coordinates of any of these points, we just have to remember that the length of the entire box is 2 pi over 3. So 1/4 of the box will be exactly pi over 6. So for example, if I want to know coordinate of this point, I'm just going to add 3 pi over 6 to the x coordinate of this point, which we already know. So adding 3 pi over 6 to pi over 3 will give me 5 pi over 6, so which will be the x coordinate of this point. And if I want to find the y coordinate of this point, I just have to add 1 amplitude to the y coordinate of this point, which is 0, and that means the coordinate will be 1/2. Similarly, we can find coordinates of any point, any special point on this graph. So this is an example of how to graph a trigonometric function using linear transformations.